Hello and welcome. In this video, we will be building a ticket booking app using NextJS, Tailwind and PostgreSQL. There will also be a couple of other packages that I will be installing along the way. In this app, I will show you how to book seats for multiple passengers, then make dummy transactions using Stripe, and finally download the ticket as a PDF. There is an app called Redbus, which operates in India and few other countries. This app is primarily used to book bus tickets, but it can also be used to book trains and flights. While the app that we will be building won't be an exact clone of Redbus, but will be inspired from it. And also, I will only focus on the bus tickets. Now, Redbus is operational all over India, but for the purpose of this video, I will consider only two routes in the state of Assam. These two routes are along the north and south bank of the river Brahmaputra, and will start in the city of Guwahati and terminate at Dhemaji in the north bank and Tinsukia in the south bank. Also, I will only consider 3 buses for the routes in both directions. I will provide a link to the repository in the descriptions below, and I suggest that you first clone the repository or at least fork it. As a prerequisite, you should have PostgreSQL installed on your computer. All the tables and the information about different buses and their route details will be present in a file called tables.sql, which will be present in the repository. I will show you how to set up the database using the file and the SQL shell terminal. Let me first start by setting up the database. So I'll open my SQL terminal and log into it. Create a new database called ticket booking and connect with it. The first table that I am going to create is that of the buses. Create table buses, ID, which is the primary key, then the bus name, then details. The details will include whether it is air conditioned or not, or whether it is of 2+2 or 2+1 column pattern. Total seats. There will be 2 categories of buses. One will contain 36 seats in 2+1 pattern and the other 48 seats in 2+2 pattern. Stoppages. This column will contain an array of stoppages that the bus will travel through in a linear order, including the origin and destination. Fare. This column will contain the per kilometer fare the bus service will charge, and it will be a decimal of 2 places. Start time. The start time is the departure time of the bus from its origin. It may or may not be the same as the pickup time of the passenger. Speed. The average speed of the bus. Service. Whether the bus will operate during the night or day. Routes. This will contain the name of the route the bus will be traveling in, also the direction in which the bus will be traveling. The next table that we will be creating is called journey, and it will contain the passenger's information and the pickup and drop-off point of the passenger and the date of the journey, the bus name and the seat number. It will also contain the mobile number and the email of the passenger. The stoppages column will contain the array of stoppages the passenger will travel through between the pickup and the last stop before drop-off. This column may or may not be the same as the stoppages column in the buses table. Fare, the total fare the passenger paid. start time, the start time or the pickup time of the passenger, payment ID. The payment ID will be generated after the payment is confirmed by the Stripe. Initially, this column will remain empty. Payment status is a boolean and the payment status will be initially false because at first only the seat will be booked, but the payment will be confirmed at the next stage. If the payment is successful, the status will be updated to true. The information in this table will be inserted after the passenger books the seat. The next table that we will be creating is as follows. The first part defines a new composite type named stop in PostgreSQL. A composite type allows you to group multiple fields together in a single data type. Name var 100. This defines the name field as a string with a maximum length of 100 characters. This field represents the name of a stop on a bus route. Distance from last integer. This defines the distance from last field as an integer. This field represents the distance in kilometers from the previous stop to this stop. The second part creates a table called bus routes. Route name column stores the name of the bus route. It's a string with a maximum length of 255 characters and cannot be null. Distance stop. The distance column is an array of the composite type stop that was defined earlier. Each element in this array represents a stop on the bus route. The array holds the entire sequence of stops along with the distances between them. The last part shows how the syntax will look like. I will now create both the composite type stop and the bus routes. Just copy and paste them here. Okay, now all the tables have been created, so I will now insert the data. I will insert first the data for the bus routes. So copy this bus route, then the next route. It is these are the same routes, but for both the directions I have to create it. Then I will insert the data for the buses. First I will insert the data for the NS37 from Guwahati to Tinsukia, direction from Tinsukia to Guwahati. In the similar fashion, I will insert the rest of the buses for the other route, that is from the Guwahati to Dhemaji and from both the directions. Now let's initialize the NextJS and install the necessary packages. First run npx create next step early test. I will name it ticket underscore booking and will be using TypeScript, ESLint, Tailwind CSS and app router. The next step is created. Now to install the packages. First I will install PG to connect to the PostgreSQL database, and since I will be using TypeScript, I will also have to install types for the PG package. This app will be a mixture of both server and client-side components. In order to make HTTP requests from the client components, I will be creating some APIs and I will use Axios to make those requests. So install Axios. Next I will install a package called date-fns that provides a comprehensive yet simple and consistent toolset for manipulating JavaScript dates in a browser and Node.js. There are a couple of more libraries that I will install like Stripe and HTML to PDF, which I will do later on in the project. Now create some local environment variables which will be used to connect with Postgres. So create a .env.local file in your root and add these variables. Username equal to Postgres, hostname equal to 127.0.0.1, database name ticket underscore booking, database password, enter password, port number is equal to 5432. Then start a development server npm run dev, and the local host is running at port 3000. Now create a new folder called utils. Inside it create a file called dbconnect.tss. In the file, first import pool from pg, then create a new instance of a connection pool for Postgres, which I will export. So export cons pool equal to new pool. Now insert all the environment variables required for connecting to the database. User process.env.user underscore name, then the host name, database name, password, process.env.db underscore password, and finally the port. Now I will create and export a default function dbconnect. This function when called will connect NextJS to Postgres. Pool.connect initiates a connection to the database using a connection pool. If there is an error, return console.error error in connection. Client.query checks whether connection is successful by executing a simple query to get the current timestamp. Then call release function. After the query is executed, this function is called to release the connection back to the pool. This ensures that the connection is not kept open and can be reused by other parts of the application. Now go to page.tsx in the src folder and remove all the boilerplate code. Declare the page.tsx as a client component and import useState from React and useSorter from Next Navigation. And also remove the existing CSS from the global.css. In the page.tsx, I will set up a background image. Next, create a div called main. Inside it, a form with method post. Then an input field with type text and name from which will be used to enter the origin. Then copy and paste the input field for the destination. Let's check it out. Then we will need an input with a type date where the passenger will enter the date of journey. The date input will have a minimum attribute of today, which I will define and declare shortly. This is to prevent the passenger from searching for buses at earlier dates. Finally, a button of type submit. Now declare today const today equal to new date to iOS hosting split t 0. Const outer equal to use outer. Now I will declare an array of type strings. This array will contain the names of all the stops and it does not have to be of any order. The places state will be used while setting up the origin. Then we have origin, destination and date of journey. These are all strings. Then we have a stop state for setting up a destination. Then we will use two arrays. One is filtered origin and the other filtered destination. The uses of all of these will be made clear in the next few minutes. Now a person looking to book a ticket does not know if the website provides bus service for his pickup and drop-off points, or if the places that he will be traveling to and from is present in the area of stoppages. So we will have to set up a search functionality for those places. For that, we have to write a few functions. First, a function to search the origin that I will call handle search origin. Const handle search origin react.change event estimate input and event. Const query, this should be a string equal to e.target.value. This query will contain what is entered in the input field. Set places query, this will update the state with the query. Const filter search result will be type array of strings equal to stoppages dot filter stop. This will filter the stoppages array if any of the elements contain the query string. Stop to lowercase dot includes query to lowercase. This is for converting to lowercase because a user might type in uppercase. Set filter origins, filter search, filter result. Filter origin array is updated with a filtered result array. In the form just below the origins input field, create a div, and within the div, if the places state is not null, we will map over the updated filtered origins array and list the name of the stoppages. The input will also have value places, and on change it will call the handle search origin and then add some CSS styles to it. The handle search origin function only listed the elements in the filtered origin array. We still have to update the state of the origin with the user choice. For that, we will create another function and call it getOrigin. Const getOrigin equal to stop, which I will pass as an argument, which is of type string. Set places stop. This will update the state of the places which will be displayed in the input field. Set origin, previous origin. This is to update the origin state and it uses a callback function. If previous origin is not equal to stop, return stop. If the previous origin is not equal to stop argument, that is the place selected by the user, then the origin will be updated by it. Else return previous origin. The getOrigin function will be called on clicking the name of the stop displayed on the list. So in the li tag we write on click getDestination and passing the stop as an argument. Remember, it will be selected only when we click on it. The method to select the destination is the same. I will just copy and paste these two functions here below and change the origin to destination. Similarly, I will copy this div and paste it below the destination input field, and on change will be handle search destination. Also on click call getDestination. Let's try it out. Really, it's not working. This would be stops in place of places. Let's try it again. Okay, now it's working. In order to set the date of the journey, in the input field for date, we will write on change event set doj event.target.value. Now I will create another function which will use a useOrder hook to navigate the user to the bus list route with URL parameters for the origin, destination, and the date of journey. Inside the search bus function, I will set up a try case block. Cons search buses try. Inside the try block, write router.push bus list plus origin ampersand destination ampersand doj. And inside the case block, console.error error fetching data error. So I will create a new folder called bus list, and inside it create a dynamic route called search params, and finally a page.tsx file which will be used to display the buses. Now in the form text on submit e.prevent default and call the search bus function on submit search buses. Let's try it out. And we are being redirected to the bus list page. The next step will be to retrieve the origin, destination, and doj from the URL. In the bus list function, I will first pass the dynamic route parameters, export default async function, bus list params params search params string. Then declare a function search args which will contain the search params const search arg equal to params dot search params. We will now decode the URL encoded string const decoded args equal to decode URI component search args, which will convert %26 to ampersand, which we will finally split the string on the ampersand character and store the origin, destination, and the DOJ by destructuring. Now import pool from the utils dbconnect directory which we defined earlier while we were connecting to the database. After this, I will fetch all the buses and the details and store it in a variable called data. Const data equal to await pool.query select star from buses. If we console log data.rows and check the terminal, we will see all the buses stored in a database. But we were looking only for those buses which run between users input origin and destination and also in that order. So we will have to write a query that will go through the stoppages array and check if both the origin and destination are contained in the array, and also the index of origin should be lesser than the index of destination. So we write select star from buses where stoppages add greater than array within square brackets $1 $2 two columns text and array underscore position stoppages comma $1 less than array underscore position stoppages $2, then origin and destination. Let us try it first. Well, there is an error. Try it again. Well, it's working. Now let's take a look at the query. This part stoppages add greater than array. The add is called the contains operator in PostgreSQL, which checks if array on the left of stoppages contains the array on the right, that is the origin and destination. This entire part checks if both origin and destination is present in the stoppages array. Now the next part and array underscore position is an operator that keeps the position of $1, that is the origin, in the stoppages array. Then the next part stoppages comma 2 gives the position of $2, that is the destination. And both in this entire query select makes sure that the position of origin is less than the destination, that is the origin comes before the destination and the bus is moving in the right direction. If there are no buses between the stops the user is looking for, then we will have to display there are no available buses along with the name of pickup, drop off and also the date of journey. Then write if data.rows.length equal to 0, that is there are no buses returned, return p class name mi4 mx10 home bus tickets. Since we will have to format the date, I will import parse ISO from the datefns library and write const parse date equal to parse ISO within parentheses DOJ. Also import format from datefns const formatted date equal to format parse date ddmmyy. This will display the formatted date in ddmmyy. Then within ptext, origin dash greater than destination greater than formatted date. Then I will place a button here with a link text that will link me back to the search page. Then finally I will write within ptext there are no available buses. To try it out, let me search for a bus between Nagaon and Dhemaji. Yes, it's working. So we managed to fetch the buses, but we also have to display them, and the goal of this component is to render a bus list in this manner. As we can see, there are certain informations that we will have to calculate, like departure time, arrival date, and fare per person. The database only stores the initial start time of the bus, and the passenger might book a seat at a later stoppage. So we will have to calculate the departure time of the bus for that passenger at that bus stop. To do that, we will use this formula: speed equal to distance by time, and time will be equal to distance divided by speed. We have the average speed of each bus stored in a database, and we can calculate the distance from bus routes table. Here we store the distance between the stops. For example, say a passenger booked a ticket from Bukaghat, and to calculate the distance from Bukaghat to the origin distance, we just add 0 plus 120 plus 120. Similarly, to calculate the total fare, we add all the distances of the stops the passenger travels through before reaching the destination and multiplying it with the fare per kilometer stored in a database. Declare a variable buses, which will be an array containing all the bus objects. Route will contain the route name since it will be common for the search. Now we will have to write a query that will give us the distance between the pickup and drop-off points of the passenger. That is the distance between the passenger's origin and destination, not the bus. This is a snapshot of the query, and it contains two parts. The first part will create a temporary table called common table expression, and it will be named stop data. A common table expression is the result set of a query which exists temporarily and for use only within the context of a larger query. We will provide the route name that will be derived from the bus data and use it to unpack the stops stored in the distance array in the bus routes table. The new table will look like this and will contain the following columns. The first one will be for the route name. Second one will contain a position of the stop in the route starting from 1. Third is the name of the stop, and last the distance of the current stop on the previous one. These data can then be used in further queries or calculations such as calculating total distances between the two stops or figuring out stop positions. The second part will add the distance between the pickup and drop-off. For that, we will have to find the positions in the table, that is the stop data table. This line selects sum distance from last. It sums up the distance between the stops along the route. Then, where stop underscore index greater than, it restricts the result to only the stop that come after the origin stop. That is a stop whose index is greater than the origin. This subquery looks for the index position of the origin within the stop data for a particular bus route. The limit one ensures that only first matching record is returned, though in this case there should be only one. Similarly, the next subquery finds the index of the destination on the same route. And stop underscore index less than equal to further restricts the result to only include stop up to and including the destination stop. That is the stop whose index is less than or equal to the destination. So we got a total distance and the distance of the pickup from the origin. Now we need to find the values of duration, pickup time, drop-off time, and cost of the ticket. We will set up a loop for cons bus or buses to calculate the values of each individual bus. Inside the first value, total fare equal to parse the bus fare to float and multiply by distance to calculate the total time amount. Next, to get the duration, total time in hours, total distance divided by speed. This will give us the duration in decimal. but we need to get a duration in hours and minutes. So the next line, const hours equal to math.floor travel underscore time underscore hours is used to extract the whole number of the hours from a floating point value representing the travel time in hours. The line const minutes equal to math.round travel time hours minus hours into 60 calculates the remaining minutes of the fractional part of the total travel time in hours by converting it to minutes and rounding to the nearest whole number. Const formatted duration equal to hours $minutes will hold the duration in hours and minutes. Const time equal to new date template details doj t bus.start time. This line creates a new JavaScript date object by combining the date of journey doj with the bus's start time bus.start time. Const time to origin hours equal to distance from start divided by bus.speed. Time to origin stores the value of the pickup time of the passenger in hours. In this line, departure time has a add-hour function from the dateFNS library that takes a date object and a number of hours as argument. It returns a new date object with the specified number of hours, that is the time to origin added to the start time, and this will be the pickup time of the passenger. Const duration ms equal to travel time into 60 into 1000. This line will calculate the duration of the journey in milliseconds. Const arrival time equal to new date departure time dot get time plus duration underscore ms. This uses the date function from JavaScript to add the total duration to the pickup time to find the arrival date of the passenger in the drop-off point. The line const estimated arrival time equal to add hours departure time travel time hours calculates the estimated arrival time by adding the travel duration to the departure time. The format function from dateFNS library is used to format a date object into string according to a specified pattern. The pattern is a combination of predefined tokens, where each token represents a part of the date. Example, year, month, day, hours, minutes, etc. The tokens allow you to customize how the date is displayed. Here I am using this library to format a departure time, departure date, and arrival date. Bus dot total fare equal to total fare dot to fix within parentheses 2. To fix will fix the total fare to decimal places. Also set the other information required: start time, arrival date, duration, origin, destination, and date of journey. I have not yet declared the bus object, which I will do in the next component, and that I will create and pass all of these as props. Now create a file named bus.tsx. This component will be a client component and will be used to display the fetched buses. Import useState from React and link from NextLink. Now I will declare the type for buses array. Bus name string, details string, total seats number, stoppages array, fare number, start time string, services day or night, origin string, destination string, date of journey string, book 6 array, route string, total fare number, estimated arrival string, duration string, arrival date string. Declare type props buses bus array. Create a functional component called buses and bus in the sub bus array as an argument. Export default buses. Inside the function, I will first create the JSX elements that will be returned. Inside the main tag, the top part of the page will be similar to when no bus. So I will just copy and paste this part here. The origin, destination and date of journey will be same for all the buses. So I will just display them on the bus at 0 index. Also copy the parsed ISO and formatted date from the parent component and paste it here. Import the buses component to the page.tsx file and pass in the bus array as props. Let's check it out. Okay, it's working. We will now construct the JSX element to display the buses. Create a section with an ID bus list. Give it display of flex and margin 10. Inside it, create a div with max width of 80% and margin auto. Now we will map over the buses array. Bus.map item index return a div with the index as key. And inside the div, create a grid of 6 columns and gap of 4. Width 100%, border gray, font size medium and margin in Y of 4. To represent the 6 columns, add an equal number of divs. In the first column, I will display bus name and bus details. Inside the p text and within parentheses, write item.bus underscore name and item.details. Add some CSS. In the next columns, we will display the start time, date and pickup point of the passenger. Let's check it out. Okay, it is working. I will add some CSS to the column. Then after this, I will display the duration of the bus journey. Now I will display the drop-off time, date and destination of the passenger. In the last two columns, I will first display the total fare for the bus and then the total number of seats in the bus. In the same column, add a button and name it View Seats. This button on click will display the seat layout if the seats are occupied or empty. This button on click will display the seat layout and if the seats are occupied or empty. OK, all the buses and the appropriate information regarding the timings are being displayed. After this, we will have to create the seat plan and provide the facility to the passengers to select a seat and also show which seats are booked and which are available. Create another file called seatplan.tsx. Before I proceed with creating the seating layout, I will add some state variables to the buses component. You see, some of the information is specific to a particular bus like fare, total seats, booked seats, and start time, and different buses might have different seat layouts. So we will have to pass this information as props to the style component, that is the seat plan component. Also, create a state called seat visibility, which will be a boolean and it will toggle the display of the seat layout. Now create a new function called handleFare and pass the following arguments: total fare, bus name, start time, total seats, and book seats. When this function is called, the book seats, total fare, total seats, bus name, and start time will be updated with the information for that particular bus. I will create another function called handleSeatVisible to toggle the visibility of the seat plan. This function will be called from inside the handleFare function. Go to the View Seats button and add an on-click event listener. This will call the handleFare function and pass the total fare, bus name, start time, total seats, and book seats for that bus. Now in the seatplan component, create a function and return a JSX element. Export it as a default function. Then import the component in its parent component, that is the buses. Inside the bus list section, create a div and insert a seat visibility state, which is a boolean and is initially false, and create another div inside it. Then insert the seat plan component again. In a similar fashion, use the seat visibility state again to create a button that will close the seat layout tab. This is the seat layout that we will have to create. The seats 1 and 13 are already booked, that is why they are marked in red. But how will we know which seats are booked and which are available? For that, we will have to write a query that will run on the journey table and check if for a particular bus on that date of journey and between the boarding and drop-off point, whether the seats will remain empty while the bus passes through those set of stoppages. If you take a look at a journey table, we have columns for bus name, origin, that is boarding, destination or drop-off, date of journey, and the stops array. The query will match each of these columns with the arguments submitted by us and will return the seat number only if all of them match. We will also need to create an array of the stops that exist between the boarding and drop-off points which the passenger submitted. For this, we will declare an array of stops that will contain all the stops that the bus passes through. Then the variable start will store the index of the origin in the stops array and the variable end will contain the index of the destination. Using these two values, we will slice the array to create a new array that will store the stops between boarding and drop-off point the passenger submitted, but does not include the drop-off itself. Take a look at the query. Declare a variable book seats that is an array, then await pull.query, select seat number from journey where the bus name equal $1 to check for specific bus, then 0 is equal $2 to check date, and stoppages 2 ampersands $3. The last part checks if any part of stoppages array in the journey table overlaps with the stop array that was created just prior to this. The operator returns true if there is any common element between the two arrays. Then pass the pass name argument, date of journey, stop array. Finally, bus dot book seats equal to book seats dot row dot makeover row dot seat underscore number. In the buses file, declare an array stop array equal to buses at 0 index dot stoppages. This will contain all the stoppages that a bus will pass through, just as we did a few moments before. Then declare start and a variable n, which will contain the index of the pickup and drop-off in the array. Con start equal to stop array dot index of buses 0 dot origin. Cons n equal to stop array dot index of buses 0 dot destination. Then slice the stop array using the start and end to get the array of the stops between the pickup and drop-off point, and not all the stoppages that the bus will pass through. The array will not contain the drop-off point as the passenger will get off the bus at that point, making the seat available. Update the stop state. In the seatplan component, declare the useClient directive and import the useState from React. Then declare the type of an object called TripObject. Copy the type declaration for the bus object and paste it here. I will just remove some of the key value pairs and change the order of the rest. Now pass all these elements as arguments in the seatplan function. Then go to the buses component and pass the props to the seatplan component. After the props are passed, we will start creating the JSS elements in the seatplan. First, add some styles to the main text. Add a div with ID bus and within it another div with ID driver. Let us look at the browser. Okay, something is being displayed. Add a nested div inside the driver div and add these CSS classes. Next, another div with ID seats. This is for displaying the seat layout. This div will be of grid type. Inside this div, add two nested divs, one for the left column and the other for the right column. The columns will have a display of grid with 12 columns, height 50% and width 100%. So what we want to achieve looks like this. To create the sheets, we will use the array function in JavaScript, once for the left column and then for the right column. There are going to be two types of layout. One will be of 2 plus 1 and the other 2 plus 2. The sheets will be numbered using the array function along with map to populate the arrays with sheet numbers. We will also need to add functions that will add the sheet numbers to an array when the user clicks on a particular sheet, and also clear the array when the clear selection button is clicked. In the sheet component, create two empty arrays called right and left. There are two types of buses, a bus with 48 seats and another with 36 seats. So we will have to use an if-else statement. If the total seats is 48, inside the block left half seat equal total seat divided by 2. Now let us populate the right array with numbers from 1 to 24. Right equal to use spread operator array half seats. This will create an empty array of length 24. Keys. Keys method in JavaScript is used to create an iterator that returns the index keys for each element in an array. Then map I plus 1 will add the numbers to the array. Now to create the left array, we use array.from. Give the length of the array as half seats. Then populate it with seat numbers which will start from 24 plus the index plus 1. Next, in the else block, there will be arrays for the 36-seater bus. We will copy the code from the if block and paste it here. The half seat will be 24 since the right column will have 24 seats and the left will have 12. In the div with ID right, map over the right array. Right.map item return div within parentheses right. Now let's check it out. The numbers are being displayed. Now to add some CSS classes. Now copy all of these and paste it in the left div. Change the right array to the left array. Let's take a look. Wait, this is wrong. This should be in 2 plus 1. In the left array for 36 seaters, put 12 instead of half seats. Okay, everything seems to be working fine now. We will now add the functionality to select seats. Create two states, one for the array of selected seats and the other to toggle the visibility of the passenger form. Create a function called handle passenger visible. This function will be used to toggle the visibility. Then create another function handle sheet click. This function will be used to select sheets. We will pass the sheet number as an argument. First, check if the sheet is already booked. If the booked sheet array includes a sheet number, then return null. And check if the sheet is already selected. Cons is selected. Selected sheet array includes the sheet number. If the sheet is already selected, remove it from the array, otherwise add it to the array or update the selected sheet state. Go to the right div and add a key and an on-click event listener. This will call the handle sheet function and pass the sheet number as an argument. Repeat this for the left div. We will also have to add some more CSS to the sheet layout to indicate if the sheet is booked or available. Add the boolean is booked to check if the booked sheet array includes the sheet number. Also add another boolean to check if the selected sheet array includes that number. Add the ternary operators to the class name. If the sheet is booked, it will have an indigo background, and if it is selected, it will have a green background. Copy these lines of code and paste it in the left div as well. Let's try it out. Okay, it's working. Now we have to display the basic information about the journey and the selected sheets. Add a div with ID station. Within p-text, display the bus name, then the boarding point and the drop-off point. After this, display the selected sheet. Add a div, then add p-text, then map over the selected sheet array. Selected sheet array dot map sheet nums return span sheet nums. Add a unique key. Add a button to clear the selected sheet array. Also a function to clear selection. Add another button that will toggle the handle passenger visible, which in turn will display a form where the users will fill in their details. This button will only be displayed if seats are selected. So wrap this within parentheses and add a ternary operator. If the selected seat array is of zero length, then a blank button will be displayed. In the clear selection function, set selected seat to an empty array. Now let us take a look. It is working, but we will need to add some more CSS styles. Now we will create the component where the passengers will enter their details and proceed to payment. Create a new file with the name passenger details. This file will contain the passenger details component. Import useState, Axios, and useOrder. Declare type for an object named passenger object which will contain bus name, origin, destination, date of journey, stoppages, fare, start time, and seat numbers. Declare type for another object, passenger form data, which will contain pretty much the same values as passenger object, in addition to which it also contain passenger's name, seat number, mobile number, and email. Declare a new React functional component passenger details and pass in bus name, origin, destination, date of journey, stoppages, start time, fare, and seat numbers as arguments. Then export it as the default component. Construct the JSX element. Add a div which will be fixed with top 0, right 0, width 30 VW, height 100%, and background white. Inside it, first display the bus name, then add a title passenger details. Go to the seat plan component and import the passenger details component. Just like we did in the buses component, we are going to toggle the visibility of the passenger details by clicking on the continue button. After the main text, enter a pair of parentheses. Get a passenger visibility state, and after the and operator, create a div which will contain a button. On clicking the button, it will toggle the visibility of the passenger details, and then add some CSS to it. Within the same div, place the passenger details component and pass the props for bus name, origin, destination, date of journey, stoppages, start time, fare and seat numbers. Let's try it out. It is working. Now we will continue working on the passenger details form. Div with class space y2, give it a title of passenger information. Within this div, add a form. Now we will map over the seat number arrays. If multiple seats are selected, then we will need to provide input fields for the passenger against each seat. In order to do that, we will have to map over the seat numbers array. Seat number.map items, which is a string, index of type number, return. Div index will be the unique key. Div class name space y2. Add a pair of key tags. Passenger, then within span parentheses index plus 1. This will be displayed as passenger 1, passenger 2 and so on. Add another pair of key tags. Here we will display the seat number against each passenger. Then I will add an input tag that will display the seat number. The form data is an array of objects to store the passenger information, which shall be created shortly. Form data index. This accesses the object at position index within the form data array. Also add an onChange event listener, which will call a function handle input change. Create the React state variable form data using useState. The passenger form data type is already declared. Seat numbers dot map seat number string dot map iterates over each seat number in seat numbers array and creates an object for each seat representing an individual passenger's form data. The variables like bus name, origin, and destination already exist as props. In addition to this, we will have to pass the passenger's name, mobile number, and email, so we will initialize them as 0. Now initialize the handle input change function eReact.changeEvent HTML input element will be triggered by the user typing on input field. Index number represents the position in the form data array. Cons name value equal to e.target extracts the name and value of the input element that triggered the event. Cons new form data equal to form data creates a shallow copy of form data to prevent direct mutation of state. New form data index equal within curly braces new form data index name value updates a specific form entry at index by spreading the current data in new form data index into a new object using name value to update only the specific field with the new value. Finally, set form data new form data This updates the state with a modified form.array. We will now create the input fields in the form. First one will be the passenger's name. On sends E, handle input sends E in dot index. Copy this and paste it here and change this to contact details. Copy the name input field and paste it here. This one will take in the passenger's email ID. Change input type to email and also the name and ID to email. The next input field will be for the mobile number. So copy and paste these lines of code and change HTML4 to phone and input type to phone. Change the name and ID to mobile_number. After this, display the total fare. To do that, multiply the fare for each passenger with length of the seat number array. Create a button with type submit to proceed with payment. We will have to create a function to post the form to the server, and we will also have to create an API to handle the request. Cons handle submit. This will be an async function. e.react form event e.prevent default. Set up a try catch block. Inside the try block, cons response await. We will use the Axios library to handle the HTTP request dot post within brackets. I will enter the URL after creating the API. So blank quotes, form data, headers, content type application JSON. After the seat is booked, send an alert that the seat is booked. Then set up the catch block. In the form on submit, call the handle submit function. To set up the API, create a folder called API in the app directory. Inside it, create a folder called bookseat, and inside it, create a file route.tsx. In the route.tsx, import pool from dbconnect and import next request, next response from next server. Initialize a function to post request, export async function, post request, type next request, booking ID any equal to empty array. Initialize an empty array to store IDs of successfully inserted bookings. Set up a try catch block. Inside the try block, variable body will contain the data parsed from JSON body from the incoming request. Await promise.all body.map, async, data, any. This line iterates over each item in the body and processes them in parallel with promise.all, which ensures all inserts complete before continuing. Inside the map, pull.query inserts the data fields from data into the journey label. The returning star clause returns the inserted record, which is then used to extract and collect the ID of each inserted booking, booking ID.post, results.rows.map, item.id. Appends each booking ID from result.row to booking ID. If all inserts succeeds, next response.json status OK booking ID returns an object indicating the success in the array of booking IDs. If an error occurs, it logs the error and returns a generic internet server error response. In the passenger details, seat number will contain the book IDs. Send in response. On receiving the response, the user will be redirected to the payments page which we create next. The URL will also contain the seat numbers, but for the time being I will comment this out. Instead, we will be redirected to the home page if the seat is booked. Let us try it out. It seems to be not working. There is a slight mistake here. In the API route, this should be bus name instead of bus underscore name. Also, I will import use order for next navigation, and when the seat is booked, the user will be redirected to the home page. Let's try again. As you can see, the seats are booked, but the ones that we have already booked are still showing as being available. In the buses component, set booked seat state should be updated with the booked underscore seat. Now the booked seats are being displayed. Okay, then everything seems to be working up to here. In the next part, we will install and set up Stripe. But please do not take it as a tutorial in Stripe because we will just make basic card payments. There are a lot of good tutorials on Stripe in YouTube. Go to the Stripe website and log in or register if you don't already have an account. In the dashboard, under the Get Started section's Developer tab, you will see two API keys, a publishable key and a secret key. The publishable key can be exposed to the public, but the secret key should be kept secure. I will copy and paste both the keys in the .env local file. I will create a new page where the passenger will make the payments. create a folder called payments in the app directory, and this will be a dynamic route. So create a subfolder by naming it within square brackets, and finally a page.tsx file. The user or users, after selecting their seats and filling in their details, will be redirected to this payments page. But even before the payments are completed, the passenger details will be stored in a database in the journey table, and a unique booking ID will be created against each passenger. Those IDs will be included in the URL, and in the payments page, the IDs will be retrieved and fetch request will be sent to the database to retrieve the passenger information. In the payments page import pool, create a function called payments. Just like the bus list page, I will use the same method to retrieve the booking IDs from the URL. Const booking IDs decode URI components booking IDs. Result will be an array of objects that will contain the passenger information after they are fetched from the database. Now write the query to fetch the passenger details. The query will run against each booking ID. So I will map over the booking IDs array and fetch the passenger info against each ID. The fetched info will then be appended to the result array. Then create a simple JSX element. Now go to the passenger details component and change this from seat number to booking IDs. Create the URL router.push payments within template details booking IDs.join. Let's go to the browser and book two seats. As you can see, the booking IDs are included in the URL. In the payments folder, create a new file, payments form. Declare the useClient directive at the top, then declare the type for an array that will contain the passenger data. This array will also contain values for payment ID that will be created by Stripe on successful completion of the payments, and a boolean showing the status of the payment. Declare the type for the props. There will be one for form data and another for booking IDs. Create a function payments form and pass in the props as arguments. Return a JSX element and export the function as default. In the payments page, import the payment form component and pass the result array as form data and the booking IDs. Now install Stripe at stripe/stripe react-stripe-js and add stripe-js. After the installation, we are going to design the payments form. In the main tag, add the following CSS. Then add a div with flex property. Then add two more divs. The first div will give the payment options, and the second div will give the information about the journey and the payments. Now in the first div, add a title make payment, give it the following styles, and then add another div. Now import elements from Stripe and load Stripe from Stripe. And then add elements Stripe promise. This I will declare now. Const Stripe public key. I will declare the public key in this file itself. And const Stripe promise equal to load Stripe, passing the public key. Let's take a look. Okay. Inside the payment form function, declare a info array that will contain the first object in the form data array. Then total fare equal to math.round info.fare into form data length. Certain information like bus name, departure time, fare per person will be same. So I will only take the information from the index 0 in the form data array. Fare per person per trip multiplied by number of passengers booking the seats at that single transaction will give the total fare. Now we will display the details of that particular trip. Div last name shadow, large shadow black, h1 info dot bus underscore name to display the bus name. Let's see. Let's console of the info. Go to the console. This will be bus underscore name. So I will change it to bus underscore name in the types. Div. This will display the departure. Name flex. Justify between. Add another div. In h2 departure. To text large font semi-bold. Info dot doz is the date of journey. And info dot start name. Start time. Next, add another div. Here I will display the seats. So for that I will map over the form data item, index, return, header list. The key will be the index, class name of flex, li item.seat underscore number. Okay, the seat numbers are displayed. Next, we are going to display the drop-off point. Div dot drop-off. Then add another div with display flex. I will just copy this part and paste it here. Since the departure to drop-off point, add flex and justify between. Let's display the boarding point instead of drop-off. I will display the drop-off after this. And this should be info.origin. Now the drop-off point info.destination. Okay. Now I will display the names of the passenger. Background of Indigo, div flex, font semi-bold, text medium, padding 5 and 4, text white. Form data dot map item index. Then return header list info item dot passenger underscore name. Give the key is index. Okay, the names are being displayed. Now we will display the fare. Div h1 fare pickup. Gives you some CSS styles. On a dot list. two list items. First one will be the onward fare and our total fare. The next one will be total fare, total payable. These two will be the same because I am not displaying the taxes and discounts and other details. Next, create a new file, checkout.tsx. This will be a client component, so declare use client directive. Then import React and use state from React. Import card element, use type and use elements from Stripe.js. Import Stripe card element from Stripe. Import Axios and import use sorter from Next Navigation. And go to payments form, copy these types for the passenger data and paste it here. Then declare the props for form data, booking ID, which will be an array, and the total fare. Then declare a functional component cons checkout React functional component props and passing the props as arguments form data, booking ID, total fare. Then export this function as a default function, export default checkout. Now declare the states for cons payment success, set payment success. This will be a boolean used initially false, used at false, calls PNR, set PNR. This will be the string. This will hold the payment ID sent by the Stripe if the payment is successful. Then cons Stripe equal to use Stripe, cons elements equal to use elements, cons sorter equal to use sorter. Save it. Then declare a ternary operator. Then within the ternary operator, declare add two divs. In the first div, add a form. This form will contain the card element from Stripe. This is a prepaid form provided by Stripe itself. And then add a button with type submit of pay disable equal to no Stripe. And add some classes for CSS. Then outside the form, add a button to cancel the payments. Save it. Now go to the payments form and import the checkout component and then wrap this inside the elements text and pass in the booking ID, total fare, and form data as props. And let's check it. Okay, you can see this form for the entering the card details. This is provided by Stripe. Now go to the checkout page and set up a handle submit function to manage the payment process using Stripe. Prevent default form function. Event.prevent default prevents the default form behavior to allow handling the submission synchronously. If not Stripe or not elements returned, ensures that both Stripe and element instances are available as they are necessary for processing payments. Cons card element equal to elements dot get element card element as Stripe card element. It types the card element where users enter card details and casts it as Stripe card element for type safety. Stripe.createPayments method is called to create a new payment method using the card information entered by the user. This returns an object containing either an error if creation fails or a payment method. If not error, meaning the payment method was created successfully, Then it retrieves ID from payment method and initiates an API call to the server endpoint at API checkout, which I will create after this. Axios.post call sends amount ID, the payment method ID, and the booking IDs. If response status from API is 200, it logs success and sets flags to indicate success. It will set the payment success state to true, and it will also set the PNR. Response data dot payment, which is actually the payment ID sent by Stripe. If an error occurs during the process, it is logged for debugging processes. Now set up a function to cancel the payments. Const cancel payment equal to async e react.form event e.prevent default. Set up a tie-case block. Inside the tie block, const response equal to await axios.post API cancel bookings. This will be an endpoint that I will create to cancel the bookings. Then I will send the booking IDs. Then headers, content type, application JSON. It will send the alert, booking cancel, router.push. Then on submit, call the handle submit function. And on for the cancel button, on click, call the cancel payment function. Now I will have to set up the routes to complete the payment. Set a new folder called checkout. Inside it, create a file route.ts. Then go to route.ts file and import next request and next response from next server. Import Stripe from Stripe and import pool from the dbconnect file. Then import and configure Stripe. Stripe is configured with a secret key from the environment variable. This enables secure communication with Stripe's API. Handle post request. The post function handles incoming request to initiate payment. Retrieve payment data. Const amount ID booking IDs equal to await request.json. Extracts the payment amount, payment method ID, and booking IDs from the request. After this, we have to create a payment indent. Stripe.payment indents creates a new payment indent on Stripe and pass in amount, the total cost of the booking, and the currency. For me, it is INR, the Indian rupees. If you are in US, it should be USD. Description: details about the payment book sheet. Payment method: the ID of the payment method provided in the ID. Confirm: immediately attempts to confirm the payment. Return URL: URL users will be redirected to after successful payment. Then await promise total booking IDs dot map. I will map over the booking IDs so that I will make a request to the PostgreSQL database to update the journey table with the payment ID that is given by Stripe and the payment status turn to true. Then I will return a response.json message payment is successful, and I will also return the payment ID. If there is an error, I will console the error and send the response as error. Now let's make a payment. Enter the card number 424242. This is a dummy card number provided by Stripe. Enter the date as 12th of 24. Let's make the payment. As you can see in the console, payment is successful. Now to create the route to cancel the payments. In the API directory, create a new folder called cancel bookings. Inside it, create a route.tsx file. Then import pull on DB connect, import next request and next response. Then export async function post request and next request. Set up a try catch block in the try block. Cons body is below await request to JSON. Await promise.all body.map async ID. Cons result is equal to await pull.query. This query will delete not only cancel the bookings but also delete the record in the journey table and enter the seats being available for booking again. Next response to JSON status okay. Console.log error. Return next response to JSON error. Internet server error. Now go to the checkout page. And in the second part of the ternary operator, I am going to display the ticket, bus ticket that will be available after the payment is being made. So set up a div with ID ticket. Inside it, give a H1 title, your ticket. Then give the PNR. The PNR is the payment ID sent by the Stripe. Now I will have to map over the form data to give the name of the passengers, their respective seat numbers, and also their contact number. So return div in the ptext passenger index +1. This will be displayed as passenger 1, 2, and such items. The passenger underscore name. Copy this, paste it again twice. Then the contact number. This is items dot mobile underscore number. Then the seat number. This will be items dot seat underscore number. Then div, set a new div here. I will give the bus name. Then the origin is the pickup point of the passenger, and the destination, that is the drop-off point of the passenger. Then the pickup time, that is the departure time of the bus from data 0 to start underscore time. total fare. Finally, a small note at the bottom of the ticket requesting the passenger to reach the pickup point at least 15 minutes before departure. Save it. Now let's book another ticket. Make the payment. SIM card number 4242. Expiry date 12 of 2024. Pay. Okay, your ticket is being displayed. Now I will set up a function to download this ticket as a PDF. For that I will use a package called HTML to PDF. First I will set up two buttons here, one for download and the other to book another. The download button will run the function to download the ticket as a PDF, and the book another will just redirect you to the home page again. For the HTML to PDF, I have to install npmi html to pdf.js. Now this package does not have any types, but since it's a TypeScript, we will be searching for the types for this package. So in order to avoid that, I will have to create a new file called html to pdf.d.ts. Inside it, write this line, declare module html to pdf.js. Now go to checkout page and import html to pdf from html to pdf.js. The bottom, now declare the function download ticket cons element document dot get element by id ticket. This id was already declared. Cons options file name, this will be the name given to the ticket in PDF file, bus ticket.pdf. Image type JPEG, quality 0.98, HTML to canvas, scale to JS PDF, unit in inches, format letter, orientation portrait. Then call HTML to PDF dot set options from element dot save. Then call the function in the download button. Let's try to download it. Okay, it is not being downloaded. There must be some error here. Okay, this should be portrait POR. Now let's download it again. Okay, the ticket is being downloaded. If you remember, I said that the seat is booked and a record is created in the journey table even before the payments are being made. But what if the user fails to make the payment? At that time, the seat will be shown as occupied and neither the passenger will receive the ticket nor the operator will receive the payments. So to avoid this, we will use a package called Cron and create a function that will run every 15 minutes and send a query to the database to check if there are any seats with payment status as false. If there are failed payments, the query will delete the entry and render the seat as available for booking. But first, we will have to alter the journey table and create a new column that will contain the time the seat was booked. Go to the SQL Shell terminal, connect to the database and run this query. Alter table journey add column created at timestamp default now. Then install the package Cron and its types. Create a file called check bookings in the utils folder. Then inside it, import cron from Cron and import pool from dbconnect and declare a variable payment underscore timer underscore minute. Set it to 15 minutes. This means that booking without payment will be considered for deletion if they remain unpaid for 15 minutes after creation. Then declare a function delete unpaid bookings. Inside the function, run a SQL delete command to remove rows from the journey table where payment status is false. And the difference between the current time now and the payment booking creation time created at is at least 15 minutes. Then console log how many unpaid bookings are deleted or log a message if no unpaid bookings are found. Then create a new function to schedule the cron job to run every 15 minutes. Export function start cron job. This uses cron to schedule delete unpaid bookings function to every 15 minutes specified by the cron expression, that is the */15 and 4 stars, and console log message when the task is running and when the cron job is initially scheduled. Then go to layout.tsx file and import the start cron job function and run the start cron job function. Now let's go to the browser and book another ticket. I will just book one seat here. Okay, everything seems to be working fine. I know this was a very long video. I hope you really enjoyed it, and I will see you on the next one.